Welcome, everybody. In this conversation, I'm really excited to welcome Jing Xie, who is the global head of go-to-market at MemVerge. Welcome, Jing.
Hey Joyce, thanks for having me on.
I think this is going to be such a cool conversation. For those who don't understand MemVerge, like what does the company do?
Yeah, happy to talk about that today. So MemVerge is a leading AI infrastructure software company. Our software does a number of things to help customers who are um, planning and running various stages of AI projects.
That's great. And can you go a little bit more in detail about how does it fit into the AI stack and
Sure.
all those things?
Sure. So I can tell you a little bit about how we started, how we found product market fit with customers. And where we actually started is in this space called spot instance computing. Um,
I don't
I
know a
don't
lot of
know
people
if,
know what that is. So
yeah,
yeah,
yeah.
what is spot instances?
So spot instances are a very interesting thing, and it stands to save you a lot of money if you know about them and you're building products and running applications on the public cloud. So what these things are deeply discounted, unused computing capacity. And this is available on every single major hyperscaler. AWS was the pioneer, so they came out with spot instances first. I think probably over 15 years ago, spot instance, this whole spot instance concept was born. And the idea is that you get to rent the exact same compute, whether you're just renting, CPUs for different tasks, or you're starting to use GPUs for AI applications. You can rent the exact same compute for many times up to 70 to 80% less than the normal hourly rate. So the first thing is that you get deeply discounted compute, like significant discounts. And the second part is you still don't have to sign up to any long-term contract. So this is basically, you should look at this as spot instances are an alternative to using on-demand, per hour instances on each of the hyperscalers. And the um, the trade-off, so you might be wondering, well, this is sounding way too good to be true. The trade-off of using spot instances is that if for any reason the hyperscaler needs these instances back, typically it's because they're starting to see more customers and users come in who are okay with paying the on-demand price and guaranteeing that they have the VMs until they're done with it. Um, each of the hyperscalers have a mechanism to reclaim or preempt your spot instance. So the way it works from the user's perspective is that on each of these hyperscalers, you'll get a very short warning. On AWS today, it's 2 minutes. On GCP today, it's 30 seconds. And then on Azure today, it's 30 seconds as well. After that warning is done, your VM or your computing instance goes away. And so a lot of people, when they hear about Spot, they say, wow, this is great. But then at the same time, this is like a new concept. So if you haven't used the cloud before, and especially if you haven't used spot instances before, you have to figure out how do you handle whatever it is that you're not done running once you get that signal that your VM is going to be taken back. And so for some customers, it's very, very challenging to use it because they don't have a good way to save their work or ensure that whatever they kicked off running continues to run all the way to the finish line to get the results during these spot instance interruptions.
So do you see customers putting production apps using spot instances, or are there particular use cases where spot use instances are a good fit? And then you guys
Mhm.
come in, it's like, we're gonna make your life easier.
Yeah. So the exciting thing, but also crazy thing for us right now is that everybody, uh, no matter organizational size or industry vertical, they all have various use cases where they want to use spot instances. Um, and our customers range from some of the top banks in the industry and top hedge funds in the industry and top life sciences companies in the industry who are using us to run on Spot better, as well as even like individual researchers or like small research labs and startups. So the crazy thing for us right now is, how do we service both markets? Because they're very, very different kinds of customers. They have very different support requirements, and they also have, different um, architectural requirements. But what we do for both of them that's the same is that for workloads where normally it would be much more challenging to run on Spot, especially in a production environment, we make it possible to now run both GPU and CPU workloads on Spot where you don't lose your work. So the application doesn't crash, your data isn't lost, whatever was being computed in the memory on that server is intact. Everything stays the same. And so that's why customers ultimately are using MemVerge is because when that warning hits and you're about to lose your spot instance, our software takes on the role of checkpointing and restoring this application or this job or this workload from the original spot instance many times to another spot instance that you can find once again, or you can restore it to work and finish running using an on-demand instance.
Interesting. And I mean that probably solved like a huge problem for your customer,
Yeah, yeah. So I would say some of our biggest customers today are running in the hundreds of thousands of cores, so CPUs and GPU types of instances. So they're running at pretty large scale. And the type of cost savings that you can then use to put into other parts of your business,
right?
whether you're a startup or whether you're a Fortune 500, everyone's looking to like how to free up OpEx and then funnel it into like, your strategic initiatives, right? So this is a really great way for companies to do that, and it's also a really great way for for startups to burn less cash.
Yeah,
And I think that what's definitely um, a new challenge in the recent years is that as more and more companies decide that they need to do something in the AI space, it requires very expensive machines like
right.
GPU machines on the cloud, cost multiple times per hour price point compared to CPU machines on the cloud. And they're not really that much cheaper if you try to buy your own and CapEx your way
Yeah.
through these things either.
So, on this point of really helping your customers navigate both perhaps their traditional, the traditional workloads on cloud on these hyperscalers, they may be using CPUs and so forth, and then the new types of workload or AI workload where they're also trying to get GPUs, but they're also optimizing costs. They're figuring out new use cases. It's pretty chaotic to manage all of that and optimize across. So going into a little bit more detail about like how MemVerge is kind of providing value or solving problems for both groups of these customers that you mentioned, both the enterprise and then, perhaps
Yeah.
the others.
Yeah, so in starting to work with some of these customers in this first product we built and found product market fit for, once we started helping these same teams save money on either CPU and or GPU based workloads that they're choosing to run on the public cloud, we then also saw a new opportunity for a second product. And the second product is for teams, many of which and many companies that we meet with are doing this, is they've decided that it's unsustainable to only get GPUs from one of the cloud providers. It's just costing them too much. And in some cases, many cases, AI is a very strategic initiative for the firm or for the company. And so they're choosing to allocate CapEx to AI. And by allocating CapEx to AI, ultimately what it means is teams are freeing up space in their existing data center environments to build up their own GPU infrastructure and their own GPU clusters. And if they
The
need
customer
space and they don't,
themselves.
Yeah, the customers
Yeah, I just want to make
themselves.
that so they themselves like, look,
Hmm.
we're gonna think about our cloud strategy. We're gonna think about our footprint. We may have
Yeah,
some stuff on the public cloud with our own instance, but we also want to sort of carve out a piece and do it our own and get our
yeah,
own
yeah,
GPU, build our own stack because of the
yeah.
unique use cases we're trying to experiment or build.
Yeah, yeah. And
Okay.
and so in many cases, companies that have been around for a while, like, banks, other types of, corporate
Insurance
Fortune 500
companies,
type of company.
industrials,
Yeah,
yeah.
yeah. In many cases, they all do still have data centers, and they use the cloud. So what we saw in working with some of these customers is that, in addition to using the cloud for AI, they're also now having to stand up a brand new type of infrastructure that previously they haven't had to set up and manage, or they've never had to set up and manage at this level of scale. And so when you have a team that's now tasked with building and managing a GPU cluster for internal usage, as well as potentially, interfacing with partners and customers, depending on what applications you build, there is now a need to manage this infrastructure. And and it creates kind of a new problem in the market, which is that how do you actually manage a whole bunch of NVIDIA GPUs? This is almost like still a well, this is still a new concept for a lot of companies because many of them, while they've gotten really good at managing CPUs, like a bunch of Intel, a bunch of AMD servers in a data center, it's not the same thing to manage GPUs. The architecture is different. The vendor support is lacking for the most part. And so, if you're going to buy all this expensive hardware, the worst thing that you want to see is that almost nobody is able to use it effectively, and your utilization is, in the low teens, 20, 10, 20, 30%, which is actually the average in the industry right now. So Weights and Biases did a study about a year, maybe a little over a year ago, where they polled all of their customers, and they found that I think over 50% of all customers, the GPU utilization is 30% or less. And part of
Effectively
that,
for their own build or in contrast to the spot instance that you rent on the hyper.
yeah,
It's like they basically have made CapEx investments. They built this, they purchased GPUs, they have their own footprint. It's kind of like reserve. So, you can use
yeah,
100%. But what you're saying is that a lot of these customers, because the way how it needs to be managed with a lot of expertise, is like use less than half in terms of
yeah,
utilization.
yeah. Yeah, so now you've spent all this money. You're committed to use, these A100s or H100s for multiple years. And um, and the problem that is now very evident is the machines are basically depreciating faster than you're actually using them for any real, value. And there's a few drivers for why this is also the case. Um, Sometimes you need GPUs for training exercises. Sometimes you need them for inferencing exercises. And then everything in the middle, you have people who are doing different types of development, small scale, research, ad hoc types of projects. And today, there's not a really great way to share and schedule a single cluster of GPUs to support all of these types of usage patterns. Training tends to take one or multiple GPUs, and it tends to take, uh, longer to return, a result, whether you're fine tuning or you're building your own foundation models. Like these tend to take a while. There's many, many epochs that you have to get through. And then inferencing is like short and fast, right? So if you just get like one really simple prompt, like, do you remember what I asked you about
Yeah, you want
yesterday?
this under a second.
Uh, yeah, yeah, yeah. You want it basically as if you were talking to a human. So inferencing is like short, fast, workloads that are not always very continuous. And then And then everybody is kind of building and making both of these better, right? Making the models better through training and fine tuning, and making the inferencing better by, continuing to build different features and functions around the LLM. So these are all very different patterns. And today, there's not very many solutions out there who can help a platform team facilitate different users to appropriately share. So what tends to happen is people hog resources. Like I request this many GPUs, and I, my team is only focused on training. So every once in a while, I'll blast them, right, for several hours or several days at a time, or even several weeks at a time. And then when I'm not running a training job or a fine tuning job, is completely unutilized, is 0%. So when it's 0% for the training team, you need a software that understands that and then can give the 0% periods to another team who might want to run short experiments or run batch inferencing where you don't need real time, but you do need to inference through some data. And you would want to give it to those other teams to use. And this is the piece of software that we built for this second product, for this second market, which is customers who have committed their compute. Now they have to figure out, after I spend all this money, I need to use it in the most effective way where I'm serving everybody's needs appropriately. Um, and so this second product addresses this sharing concept and this scheduling concept. And we use the same technology that we harnessed in the very first product, which is this checkpointing thing. And we repurposed it. So instead of saving you from a spot interruption, what checkpointing does in the second product that MemVerge built is it helps you do what's called graceful preemption. So let's say you have the training team and they're hogging all of the GPUs right now. And there's this other team that wants to run a very small inference test that could only take 5 or 10 minutes, but it's very, very high priority. Like they need to get back to a customer with a demo, or they need to get back to the R&D leader with the results, right? And they can't afford to wait 3 more days for the training job to finish. Graceful checkpointing or graceful preemption allows you to take the training job off the cluster, off the machines, without killing the progress of all the epics and everything that was already done up to that point. And then it allows the second team to go and run their 5, 10 minute job, inferencing whatever experiment, and it puts the training workload back in. And then nobody is killed. Like nobody's job is actually crashed, killed,
Right.
canceled. And in today's research clusters, whether it's universities or in the enterprise, people have to make decisions to kill other jobs just to run other ones when the utilization is full. And so this is a really nice feature that falls within this whole scheduling and resource management product for this second team.
I think very cool and make a lot of sense. So, like, how does MemVerge do this? Like, tell us a little bit more about, is this sort of
Yeah.
optimization, is this orchestration, is this like virtualizing, different things?
Yeah. So for this second product, what we had to do was a number of things. The first was we worked with the NVIDIA CUDA team for the better part of almost 3 years now. And we were able to take a facility that they built called CUDA Checkpoint, and we basically mapped out the rest of the journey to take and use CUDA checkpoint and complete a full, application checkpoint, which includes the GPU memory, the CPU server memory, and all the associated files, so that you can do something like this graceful preemption. So instead of killing that training workload, you're just pausing it, bringing it down
Yeah.
to storage, running the other person's work, and then restoring that other team's training job. So we've been working really closely with the industry, and we're also doing the same thing with AMD. So we're also cross-vendor. That's something that we don't see very often and that customers are increasingly asking for is cross-vendor support. I have one cluster. It's not going to be just NVIDIA and it's not going to be just AMD. We want a solution that can help manage heterogeneous vendors. It does that already. And we also had to build some scheduling, some smarter scheduling that understands these concepts of like graceful preemption using our checkpoint technology, et cetera. So we built on top of a project that is really, really nice and being driven forward by the open source community. It's called Kubernetes Q, Kueue. And it's a Kubernetes-based scheduler. So we built an enhanced Kubernetes queue So we stay with open source support for like call it the core Kubernetes projects and infrastructure that people care about, and we built this nice management layer on top. So now you have a way to manage scalable clusters that get bigger over time, and you can schedule resources and workloads, and these resources and workloads scheduled by Kubernetes queue. And what we've done, it understands that you also sometimes need to checkpoint them, or you need to like have abstraction layers on top to track different departments and who's using what and how much of the cluster is being used by which groups. And so we're kind of building out more enterprise use cases on top of some of the really great open source projects going on today.
Very cool. So talk about sort of the what's coming. So you started with helping customers optimize Spot instances across hyperscalers. Now
Yeah.
you are in the optimizing GPU AI infrastructure
Yep.
from the infrastructure all the way to the apps, right? To what they need to do in production, what's in production, and help them manage that and increase the utilization of their very expensive AI infrastructure that they kind of own. So
Yeah.
they want better utilization of that, but also be able to provide to all kinds of users internally for the different projects they're building. So what's next?
Yeah, so we kind of started with, help customers optimize their budgets so they can actually do AI.
Yeah,
And that's the spot. And then we're now helping customers optimize the new investments, which are these AI clusters,
yeah. And
whether
like Gen
they're
AI and much
yeah,
a different kind of workload and projects added
yeah.
to the existing ones.
Yeah, so then naturally we started to move up the stack, right? So first just basic like how do I free up budget? Second is how do I make the most of this new investment and CapEx that I'm spending? Um, and then third is okay, now I'm going to build something. So I'm going to build hopefully good applications that either um, increase productivity or generate revenue, right? At the end of the day, like if you're doing a project with AI, it needs to be measured upon some sort of ROI. And where we found a really interesting and complementary area to then focus on for our third product is it's an area called intelligent memory. And so intelligent memory is useful for teams that are now building different chat-based AI advisors, assistants. And it's for teams that have various reasons to not be able to use ChatGPT or perhaps Perplexity or some of these other kind of like opinionated general chat assistants. Like they may have a very specific use case where they don't need to use such a big model because it's too expensive, and they need to basically create their own user experience to best deliver this specific use case that they're solving for. But they still need to essentially build an application that has the ability to chat and interact with humans. What intelligent memory does is it addresses probably the first thing that most teams will realize once they go down this journey of building their own LLM chatbots. And that is most of them don't come with all of the features that people, almost view as like table stakes today when they use ChatGPT. And in many cases, when I talk to customers, they think ChatGPT is equal to LLM. Like ChatGPT, they think is an LLM. But ChatGPT is much more than an LLM. It's all of the middleware and kind of call it features built around OpenAI's LLMs that actually make ChatGPT what it is today. And so when people start building with LLMs directly, they realize very immediately that LLMs themselves have no memory. They don't remember anything. If you asked them, if you asked an LLM one question and then you subsequently followed up with another question um, a few hours later, or maybe even the next day, you would have to start over again and remind the LLM whatever it is you asked for, and it helped you with the first time. And so that's because LLMs themselves don't have a very long memory window. And so one of the first things that intelligent memory does is it's a piece of software that is given to developers to help them stand up a backend with the LLM of their choice, and gives the LLM the ability to have this feature called memory. So now if, Joyce or Jing talks to this LLM tool that is being built, it has the ability to remember that last time when we were chatting, it can recall that we were, I don't know, talking about the new awesome restaurant in New York City, right? And it can then go from there to help me with like a more advanced question, like book a reservation at
Yeah.
book a reservation at that restaurant that I can't remember the name of, but we talked about it last week, right? Like you could say it very, very humanly. Like you don't have to perfectly, remind it every little detail. It should remember the context of what you mean when you say book a reservation at the restaurant I asked you about yesterday, right?
Yeah.
And so that's what intelligent memory does. It shortcuts the application and development cycles to build a very advanced chatbot like people are used to seeing when they use a Perplexity or a ChatGPT with a paid subscription. Like it remembers all your stuff. It starts to even personalize and profile your preferences. And so certain questions where you want the answer delivered in a particular format or a particular way or a particular length, it starts to profile and remember your preferences as well. And so intelligent memory is this nice software at that level. Once you're actually building stuff, now that you have all the infrastructure, you can get to the finish line faster with a better application that hopefully gets adopted and used by the end users that you're designing for.
And is the way sort of the way you do that is like you know, like take the example that you talked about with the restaurant is, it store what we talked about, but it also associate with the fact that we were the two who were having that conversation at that particular
Yes,
time, and then turn that into something that can be provided as additional context the next time someone query or you and I will use um,
yes,
that engine.
yes, exactly. And we're starting to get requests from customers to support this not at the one-to-one level, but
Right.
like at the LLM to group level. So let's say like we're an event planning company and you started having a conversation and getting the AI to help you with some things. And then you had to take a business trip for a few days. And then you passed on the project to continue planning this event over to me. I
Yeah.
could go into the same AI tool or application, and it would remember that we're part of the same planning team or business. And you were starting to go on this research journey to help create this amazing event for this customer. And now you're away for 3 days, and you can even tell them that. And the agent would remember you're away for 3 days. And
Yeah.
I could come in and say, well, where did Joyce leave off in terms of planning, and what else do we need to do from here? And then it would engage with me as a handoff point naturally. I don't have to go and start this event planning conversation again for this exact same
Or talk
event.
to other people about, hey, where Joyce
Yeah,
left off,
yeah,
and this is what
yeah,
Joyce told me. Are there
yeah,
anything I need to know?
yeah, exactly. So it does all this nicely, and you can use it for the purposes of like a use case such as event planning, but the same type of group memory is helpful when you're working with more than one software developer. So you could have a software development team, two, three, four people, and they're all building things, and the coding assistant needs to remember things across multiple people. And maybe the QA team can then come in and start QAing the functioning code, and they might have some questions where the memory is important to them. And so this concept of memory, I think, is a key layer for building like truly great, useful AI assistants. And so this is the third layer that we're now seeing people move to once they actually have infrastructure to go and build AI. And so we're also now working with customers on this third layer. And so we've just kind of been moving like gradually up the stack.
I
The
think
stack.
very
We
cool.
started with just like checkpointing technology, then we're like AI cluster infrastructure management technology, and now we've moved to the very top of the stack or towards the top of the stack, which is just AI developers who are building their first AI application and they're playing around with and experimenting with different LLMs. So we now give you this ability to do much greater things with any LLM and not be dependent on, call it only the market leaders,
Right.
which do also happen to be the most expensive.
Yeah. Or like force your LM to like just
Yeah,
memorize or like figure out how to like elongate that context window, but it's like one to one, right? When you have like thousands of
yeah,
users and thousands of conversations. And this
Yeah.
is really not retrieval because it's not static information. So what you're
Yes.
doing, I think, is complementing a lot of the things that are in place, but giving developers um, another really powerful tool to help
Yeah.
them rapidly build large language model based or generative AI apps, and without doing huge amount of sort of work to like break that model apart or fine tune it or some other things around it. It's a
Yeah.
sort of
And there's
discrete kind of set of skills that you're adding to large language model through software, through optimization, which is sort of the heritage of the company.
yeah, and there's also a security aspect to this too. So most enterprises view their data as, very sensitive and they want to protect it, but they also want to unleash AI on it, right? So then the question is, well, how do I do that in a way where I don't make mistakes that cost the company a lot of money or leaks sensitive IP or even
Right.
exposes trade secrets and process knowledge out to the
Yeah.
internet, right? And so I think they've already figured out how to do one step of this, which is, I have my enterprise data, I create RAG. RAG lives in my virtual, network,
Yeah.
secure network. And at least when it comes to enterprise data, my solution is to do some data engineering and create all of these kind of
Yeah.
RAG data sources, right?
Right. And or
And
like
I make
the
sure that
large
that
language
doesn't.
model that my version sits within my environment, not share with anyone else.
Yeah, so then they've taken care of the data, but then what I've noticed is this, and I think this is a subtlety that not every enterprise has fully thought through, which is even if you've set up your data securely and you've set up your RAG environments, you are still going to run the risk of exposing sensitive information, potentially trade secrets, process knowledge, and even IP if you don't do the memory layer correctly. So what I mean is this: some companies are saying, okay, now I have RAG, and then I'm just going to go start using ChatGPT against my RAG. That's a big problem potentially because even though ChatGPT says they won't store your enterprise data and all of this other stuff, what happens is that you're extracting information from your enterprise data sources. It's going through a conversational history that ultimately lives and stays in, let's say, OpenAI's servers or Microsoft's, OpenAI, LLM hosted servers. And so you're giving somebody else stewardship of data that's been extracted from all your secure data sources, and you're giving them stewardship during this processing window, right? This whole conversational log. So what's called session log and what you then deliver to the LLM, companies need to think about how to protect that stage of this as well. So one level that's better than once I've set up RAG, I can just connect ChatGPT to it. One level that's better than that is if you like OpenAI's models, great. Still use the LLMs. We discussed earlier they don't have the ability to remember anything. But you should keep all your session logs and essentially your memory layer. You should keep that in the enterprise as well.
Yeah.
And so that's why we built this third product. This third product is for companies who understand that even if you've protected your so-called resting state enterprise data, when it goes in transit to get processed by an LLM, you need to protect basically the highways that it's running on. And so the intelligent memory layer is essentially the memory and semantic layer and session logs, essentially your chat history, all of that rich back and forth discussion. All of that should also, in my opinion, live within the enterprise domain in full control. And then from there, you can use either an LLM that you stand up and host yourself, or you can just shoot an API call to, OpenAI's LLM or Anthropic's LLM or somebody else's LLM. But you've basically protected as much of the window of your data, kind of your data lifecycle as you can.
Right.
And that to me is one thing that I don't see as very clear today with most of the enterprises as they adopt. Like it's not super clear to most teams what they're exposing when they start using the third party, call it memory and LLM layer.
Yeah. Yeah, it's
Yeah.
also as if things are moving so fast and like all these different components, organizations really need to think about this kind of the technical design plus the user design plus all the different secure design and
Yep.
all together. It's sort of like a new paradigm with like the new AI infrastructure all the way to the app layer. Um, so we are running up on time, but one question is, you've been doing leading go-to-market for high-tech companies, startups, especially in the enterprise space for a while. And there's a lot of talk about how go-to-market for current AI companies is different because it's like so competitive. Organizations are also building, like everything just move faster, and there are so many players out there. When you think about go to market for AI companies and when you're looking for talent, what are your thoughts?
Yeah. I said this in um one recent podcast, but I think it's also relevant to repeat here is like I feel like everyone is just getting their bachelor degree in AI. So one way to look at this is that no one should feel like they're that far behind anybody else. So if you are uh, let's say you're someone who wants to transition your career from an area that wasn't associated as, AI stuff into an area that is now associated as AI or generative AI. I would, one thing I want an audience to take away is that no one should feel like they can't catch up and they're too far behind because I think everyone is learning and everyone's just trying to keep up with like the latest, what happened this week because it's all moving so fast. But,
Yeah.
you know, the whole ChatGPT product didn't really capture all of our imaginations until only like 2, 3 years ago. And so no one really was spending very much time becoming AI experts until about 2, 3 years ago. So the folks who started almost immediately upon seeing ChatGPT and the promise of what this technology could hold, they're only like in their junior year of getting their bachelor's degree in AI, right? And so even if you started today from brand new, you're a freshman, so you're only 2, 3 years behind anybody else. And so if you're somebody who is, curious and works hard and has the right, call it like core building blocks to learn, I think that that is what is very important. And that's something I look for when I hire people to join the team, but also just for everybody who's interested in like an AI career, no one should feel like they can't catch up or that they can't do this because everyone is very much still like a bachelor's degree, with a few exceptions. Like the people who are getting offered, 100, $200 million a year by Facebook or Meta to join them from OpenAI, maybe they know a few things that are like maybe they're like closer to a PhD. But I think most people are basically just bachelor's degree. They're getting the bachelor's degree. And I think that's one key takeaway I want people to remember. And I do think that enterprises that have money, that have decided that AI is a priority for them, strategic initiative, they've all like properly invested at a level in which there are teams at every enterprise that want to do things themselves, maybe only because also they want to learn because they're also bachelor's degrees in AI. But like everyone is trying to both build everything themselves to kind of get their hands on the whole stack and experience it. And at the same time, they're all evaluating vendors who can help them speed up a particular part of the stack. So it's like very noisy from that standpoint. Like
Yeah.
everyone's trying to build, and then there's another team that's like, I've already had enough. I don't want to build. And then they're gonna eventually get to a steady state where everyone figures out what they really want to build and focus on and what they want to just outsource and buy some services or buy a software product to help them. And so I think we're very much in the middle of that. And then um, the other thing as well is that many companies are also in the middle of reorganizing so that they better align the people behind the strategic priority. So there's also a lot of people changing job titles. And so from a go-to-market perspective, it's not it's not very simple to find the right person. So there's definitely some extra work involved in getting to the right person, having the right meeting, and then making sure that that person actually has decision-making authority because all of that is like being reorged as
Yeah.
we speak.
Yeah.
So I think those are like maybe unique challenges from the go-to-market side, selling AI into the companies. And then also, the earlier message was really just around, people who are interested in AI careers.
I think that's great encouragement and this focus you talked about on learning and I agree with you on the changing landscape on the enterprise buyer side. Hopefully things will settle down soon and make all the AI startups jobs easier. But it's
Yeah.
definitely a very interesting time to really bring this innovation to different organizations. Thank you so much, Jing, for telling us more about MemVerge today. Very fascinating and for this conversation.
Yeah, thank you. I enjoyed it. Thanks for having me on, Joyce.